All right, we're going to look at radical equations right now. Now, I want you to really think through these without even touching your pencil to the paper. I have something minus 4 equals 0. Well, that something has to be 4, right? The square root of what gives you 4? Well, that one's really easy. The square root of 16 is 4. The next one, the cube root of what equals 2? Well, gosh, I know that's 8. Now, the last one can be tricky for some people because this is different than having x squared equals a certain thing. The square root of x equals negative 5. Now, I want you to think back. If you think about the graph, the radical function, its domain, the x's are all positive numbers, and also the range. Our output cannot be negative. So this is the empty set or no solution, however you want to write it. Our output of an even function is only positive. Now, odds, if this had been a negative 2, I'd be okay, because that would mean that it would have been negative 8 under here. So I really want to make sure that's clear. So when we're solving equations, that's one thing we want to look for. What's under the radical cannot be negative, and the output of a square root cannot be negative. All right, so there's some simple steps to solving radical equations. And if you are taking notes from this video, I would advise pausing and writing this down. Number 1, we're going to isolate the radical. Get it on one side all by itself. Then, if we raise both sides of the equation to a power that is the same as the index, we're going to get rid of that square root or cube root. Next thing we're going to do is going to solve for x. Well, solving equations, that's what we do. And the last thing we need to do is to check our answer. We need to make sure that our answer is part of the domain. If it really works. Is it a true solution? So we're going to have to plug it back into our original equation. People try to skip this step. Do not skip the step of checking your solution. Even if you're doing it mentally, I want you to make sure you think about, is this answer a logical answer? Does it work? All right. So let's look at some examples. And I have several examples to go through. Square root of 3x minus 2 equals 4. So we want to have the radical isolated, and it is. So now, we're going to raise both sides of the equation to a power that is the same as the index. In other words, just the square root to undo a square root. We square both sides. We know this already. Those were just fancy words. We're going to square that side and square the right side, because what thou doest to one side, you must do to the other. You have to keep it balanced. Now, when we square a square root, they undo each other. So what are we going to be left with? 3x minus 2. And over here, 4 squared, that's going to be 16. Now we just have a simple equation. We're going to add 2, and I get 3x equals 18. Divide by 3, x equals 6. Now, I want to check my answer. So I'm going to change colors here. I'm going to go back to the original. And I'm going to say the square root of 3 times 6 minus 2. That's 18 minus 2, which is 16. Is the square root of 16 4? Does this equal 4? Yes. The solution has checked out. Let's look at the next example. Square root of 3x minus 2 equals negative 4. Hey, wait a minute. We just talked about this. That is not going to work. A square root cannot be negative. A square root cannot be negative. So this would be no solution, or null set. Number 3. Negative 2 times the cube root of 2x plus 5 plus 7 equals 15. So now this one we're really going to have to isolate that radical first. That is going to be a very big first step. So we're going to walk through it step by step. To get this by itself, we don't want that plus 7, so let's subtract 7 from both sides. If I subtract 7 from here, it'll be gone, and subtract 7 from 15, and I get 8. Now, we have negative 2 on the outside, and that's multiplication. So to undo that, we divide both sides by negative 2. When I divide 8 by negative 2, I get a negative 4. Now, I want you to pay close attention. This is a cube root. Is it okay for a cube root to be negative? Yes, it is okay for a cube root to be negative. So now, we look at the index. It's cubic. So to undo a cubic, we're going to cube it. When you cube a cubic, or a cube root, you get the radicand comes out. Negative 4 cubed is going to be negative 64. Subtract 5, and we get 2x equals negative 69. X equals negative 69 divided by 2. I want to check my answer. So I'm going to plug it back in. And you could do this in your calculator as well if you wanted to save time. But the main things we're looking for are negatives under an even radical. And we're looking for things that don't make the right side true. Cube root of negative 64, that's a negative 4. That'd be 8 plus 7. Does that equal 15? Yes, it checks out. Go with number 4. All right, so again, we have something being added to our radical. So we need to move it. So I'll need to subtract 5 from each side. That would give me x minus 5 on the right. Now that the radical is isolated, I need to raise both sides of the equation to the same exponent. So since this is square root, I'm going to square both sides. And I want you to be very careful here. When we square x minus 5, that is really x minus 5 times x minus 5. So when I do that, that's x times x, which is x squared. I'll have negative 5x and negative 5x, that's negative 10x. And then negative 5 times negative 5 is going to be positive 25. Now, I have a quadratic, so I want to get everything on the same side. So I'm going to subtract x. It's going to give me a negative 11x. And I'm going to add 3. It's going to give me a 28. So we want to isolate that 0 when we have a quadratic. Now, we hope it factors. Wasn't this nice enough to make it factorable? X times x gives me x squared. What multiplies to be 28 and adds to be negative 11? It's going to be a negative 7 and a negative 4. So using the zero product property, I know that means that x minus 7 equals 0 or x minus 4 equals 0. So one of my solutions is x equals 7 and 1 is x equals 4. I have to check both. So don't try to be sneaky and just do one. You've got to check both. So let's start with the 7. 7 minus 3, and then plus 5. We want to see if that equals x, which in this case is 7. I'm going to put a little squiggly line so I can check my other x on the other side. That's going to be the square root of 4. Square root of 4 is 2. Does 2 plus 5 equal 7? Yeah, so that one checked out. Let's try the other one. 4. Okay, square root of 4 minus 3 plus 5. Does that equal 4? Okay, 4 minus 3, that's 1. Square root of 1 is 1. Does 1 plus 5 equal 4? Not in this century. So this is what is called, let's see if anybody remembers the name of it, it's called an extraneous solution. An extraneous solution is a solution that you arrived at through proper algebra, but it is not a correct solution when you check it. So when you go back and check it, it does not work. It is a bad solution. So we only have one true solution to this problem. All right, the next one. Number 5, I believe. Number 5, yes. Number 5 is alive. Okay, square root of 3x plus 2 minus the square root of 2x plus 7 equals 0. Okay, so if we see this one, the square root, let's isolate that one. So I'm going to move the other one to the other side. All right, now since we have a square root, we want to raise both sides of the equation to the same power. That means we're going to square both sides. Ooh, this might work out nice. When you square a square root, you just get your radicand back. Square a square root, just get the radicand back. Subtract 2x, get x plus 2 equals 7, so x equals 5. Can I move on to the next one, or is there something I'm forgetting to do? There's something I'm forgetting to do. I must go back to the original. Square root of 3 times 5 plus 2 minus the square root of 2 times 5 plus 7. Does that equal 0? 3 times 5 is 15. So that's 15 plus 2. That's going to be 10 plus 7. Square root of 17 minus the square root of 17. Does that equal 0? Yes! So it's a good solution. Last example. Number 6. Square root of x minus 5 minus the square root of x equals 2. Now we do have two radicals here, but let's just keep with the same approach. Let's isolate this radical. I'm going to get him all by his little self. I'm going to add the square root of x. So on this side I'll have 2 plus the square root of x. Same routine. Going to square both sides. If it had been a cubic, I would have cubed both sides. But it was a square root. So I get x minus 5. Now over here, don't forget, when you square a binomial, write it out. And let's see what we have. 2 times 2 is 4. 2 times the square root of x is going to be 2 square roots of x. Square root of x times 2 is 2 square roots of x. And then the square root of x times the square root of x is just x. Now let's clean it up a little bit. I've got x minus 5 equals 4 plus 4 square roots of x plus x. I want to isolate my radical. So let's leave this here, and how about if we subtract the x And then let's subtract the 4. Okay, so let's see what we have left. Ooh, those x's canceled out. That's nice. I have negative 9 equals, that's gone, 4 square root of x. Negative 9 divided by 4 equals the square root of, uh-oh. Can a square root be negative? No. No solution.